Hello students, today let us learn about the quadratic equations. To know what are the quadratic equations, we start with the general form of quadratic equations. So the standard form of quadratic equation is ax square plus bx plus c is equal to 0, where in the equation ax square plus bx plus c is equal to 0, a, b and c are any real numbers, and one condition is given here that a must not be equal to 0. Because if a is equal to 0, then 0 into x square, that term will be eliminated and we will have bx plus c is equal to 0. And if we consider bx plus c is equal to 0, it is not a quadratic equation because the highest power of the variable involved in it is not 2. That's why that will be a linear equation. So therefore there is one condition given that a must not be equal to 0. So here is the general form of quadratic equation ax square plus bx plus c is equal to 0, which is a quadratic equation in variable x, and a, b and c are any real numbers. Now based on that we have one question. Decide which of the following are the quadratic equations. So some equations are given below. First is 3x square minus 5x plus 3 is equal to 0. 9y square plus 5 is equal to 0. Then the third equation is
L plus
m
2
cube minus 5m square plus 4 is equal to 0. And fourth equation is into another bracket L minus 5 is equal to 0. We have to decide which of these four equations are quadratic equations. So let us consider the first one. In this equation, 3x square minus 5x plus 3 is equal to 0. X is the variable and the maximum index of the variable is 2. So if it is the case, then we say that the given equation is a quadratic equation. So 3x square minus 5x plus 3 is equal to 0 is a quadratic equation. Let us have the second example. 9y square plus 5 is equal to 0. Now for this equation, 9y square plus 5 is equal to 0. First of all, we have to find the variable. So here y is the only variable in this equation, and as we can see, the maximum index of the variable y is 2. So both the conditions are satisfied in this equation. That's why it is a quadratic equation. It is 9y square plus 5 is equal to 0 is a quadratic equation in variable y. Let us have the next equation. M cube minus 5m square plus 4 is equal to 0. Now for this equation, the variable involved is m. So m is the only variable. So the first condition to be a quadratic equation is satisfied over here. But here the maximum index of the variable is not 2 because the maximum index is 3 here. So the second condition to be a quadratic equation is not satisfied. That's why the given equation is not a quadratic equation, as the maximum index of this equation is 3. So it must be 2, then only we can have the equation is a quadratic equation. Let us have the next example. In first bracket L plus 2 and in the second one L minus 5 is equal to 0. Now at the present form we can see that it is not a quadratic equation because the variable L is there and its maximum index, we might feel that it is 1, but we have to simplify this one because L plus 2 into L minus 5. So these two expressions are in product form. First of all, we have to simplify this. So we have to multiply each term in the second bracket by each term in the first bracket. So that is, we have to multiply L minus 5 by L, and we have to multiply L minus 5 by 2. So L into the second bracket L minus 5 plus 2 into L minus 5, that is equal to 0. If we multiply L into L, that's L square, minus 5 into L, that's 5L, plus 2 into L, 2L, minus 2 into 5, 10 is equal to 0. If we simplify this, we get L square minus 5L plus 2L, that will be minus 3L, minus 10, that is the constant term, is equal to 0. Now, as in this equation, the variable L is there, L is the only variable, and as we can observe, the maximum index of the variable L is 2. So both the conditions to be a quadratic equations are fulfilled here. That's why the given equation is a quadratic equation. So out of these four, first equation, second equation and the fourth equation are the quadratic equations. Now let us have one activity. We have to complete the following table. So here the equation given, we have to write that equation in the standard form, that is the general form, and from that we have to find the values of a, b and c. So the first example is given x square minus 4 is equal to 0. As we can see here, the middle term is not given. So we can express that x square plus the middle term can be written as 0 into x, because 0 into x again will get 0. So that will not make any change to the present form of equation. So we have just expressed this as x square plus 0x minus 4 is equal to 0. Now if we compare this equation with the general form of a quadratic equation, instead of a we have 1, that's why value of a is 1 here. Instead of b we have 0, that's why b is 0. And instead of a constant term, 4 is there along with the negative sign. So we should take the value of c as minus 4. Now we have to solve the second equation. Y square is equal to 2y minus 7. So first of all, we have to write this equation in general form. That's why for that one, 2y minus 7, we have to take that to the left hand side. So as to get the equation, y square minus 2y plus 7 is equal to 0. Plus 2y going to the left hand side, it will be minus 2y. Minus 7 will become plus 7. So this is the general form of a quadratic equation. And now we can compare it with the general form. Instead of a, we have the coefficient of y square as 1. That's why a is equal to 1. Value of b is minus 2 along with the minus sign, and the value of c is 7. So these are the values of a, b and c for the second equation. The third equation is x square plus 2x is equal to 0. So as we can observe here, the constant term, that is c, is not given here. So we can write that x square plus 2x plus 0 is equal to 0. Because the constant term is not given, that's why we can write it as plus 0. Because if we add 0 to any expression, that will not change the value of that expression. So if we compare this with the general form of a quadratic equation, we get the value of a as 1, value of b as 2, and value of c 0. These are the values of a, b and c for the third equation. So this is how we can find the values of a, b and c, the general form of a quadratic equation. Now let us know one concept, roots of a quadratic equation. First of all, let us have the definition of that. The value of variable which satisfy the given equation are called solutions or roots of the equation. For example, let us have a polynomial x square plus 5x minus 6. So this is the polynomial in variable x. Instead of x, if we put minus 6 in this polynomial, we get x square plus 5x minus 6, that is equal to minus 6 square plus 5 into x, that is 5 into minus 6. So minus 6 square, that is equal to plus 36, plus 5 into minus 6, that's minus 30, minus 6 as it is. Minus 30 minus 6, that's minus 36. So 36 minus 36, that's 0. So we get the value of this polynomial x square plus 5x minus 6 is equal to 0 when x is equal to minus 6. In this case, we can say that x is equal to minus 6 is the solution of the given equation, because if we substitute the variable x by minus 6, at that time we get the value of that polynomial at 0, and hence minus 6 is one root of the equation x square plus 5x minus 6 is equal to 0. We must note that every quadratic equation has two roots, as the maximum index of the variable is 2 here. That's why every quadratic equation has two roots or two solutions. Now let us have one activity based on this concept. It is, if x is equal to 5 is a root of equation ax square minus 14x minus 5 is equal to 0, then find the value of k by completing the following activity. So the first step in this activity is, one of the roots of equation kx square minus 14x minus 5 is equal to 0 is, it's given to be 5. So we should fill here, as x is equal to 5 is the root of given equation, we have to substitute x is equal to 5 in this equation. So we have kx square. Instead of that, we can write k into 5 square minus 14 into x is 14 into 5 minus 5 as it is equal to 0. So 5 square, that's 25, and 25 into k, that's 25k, minus 14 into 5, that's 70, minus 5 is equal to 0. So 25k minus 70 minus 5, that will be minus 75 is equal to 0. If we take minus 75 to the right hand side, it will become plus 75. So we get the equation 25k is equal to 75. We have to find the value of k. That's why we have to transfer 25 to the right hand side. So it will be in the denominator. So as to get k is equal to 75 divided by 25. If we simplify here, 25 3s are 75. That's why k is equal to. So here, for this problem, the value of k is. Here we have used a principle that if x is equal to 5 is the root of the given equation, if we substitute the variable x in the given equation, the value of that equation must be equal to 0, because x is equal to 5 is the root of the equation, or x is equal to 5 is the solution of this equation. By using that, we have solved this problem to find the value of k.